Hello all, welcome to another Clojure diary video. So I was just thinking like what are all algorithms we can implement it in Clojure. So like I just got hold of this book like classic computer science problems in Python. So one of the problems they say is like about Fibonacci and so like yeah, it is a very classical problem, like very good for functional programming language. Yeah, I'll be putting the link of this book in my blog so that you can also buy it and read through it. So like yeah, I just want to explain what Fibonacci is. Okay, so to explain it, let me just put a new text file like Fibonacci dot txt. Okay. So Fibonacci is like this. You have two initial numbers, 0 and 1, right? Okay. So now what will happen if you add 0 and 1? So you'll get 1, right? And what will happen if you add the previous two? 1 plus 1 is 2. Okay. So what will happen if you add the last two? It becomes 3, and then similarly 5, 8, 13, 21, and so on, right? So we can give indexes for this number. Okay, this can be indexed as 1. I don't like 0 indexing for some reason. Okay, 2, and similarly, yeah, 3 and 4 and 5. Okay, these are all tab 9 completions. Okay, so 6. I am doing free marketing for that for them, right? 6. Oh god. So okay, tab 9 is not always interested. Okay, 7, 8, 9, and so on, right? So okay, then we put everything, right? Okay, so 8 and then 9, right? So right, yeah, yeah. You can just keep on going on. Like, what is 21 plus 13? It's 31 plus 34, right? So that's it. Yeah, you can just keep going on and on. So that's how it is. So yeah, let's write a Clojure program for that, right? Okay, so um, let me just okay, I don't know what happened over here, right? Okay, so this VS Code is a bit confusing sometimes, right? Okay, so let me just put a thing, fibo.clg, right? So that's my file name, right? Uh, okay, so let's have a function called fibo, right? And that will take index. Or let's have it just like fib. Okay, so index. And then depending on the index, it will return something. So now let's just return 7 or something like that. 7 is not a Fibonacci number. So what I just want to do is like I just want to test the ripple and all those stuff. Okay, so that's the thing, right? So let me just start the ripple. Okay, so go to my terminal or whatever item or whatever you have. Like I'm ashamed to use a Mac. I want to put Asahi Linux, but yeah, let's see. Like I don't want to mess it up, okay, because my work depends on it. Okay, so oops. Okay, so let me just okay. I just forgot what I need to do. Okay, yeah, lean ripple. Okay, okay. It gives like 63366 and all those stuff. Okay, so let me just do it. Okay, ripple generic. Okay, right. Okay, so you just got it. Okay, so you've got this fib. So okay, fib is over here. That's good, right? So let's put like okay, like fib of 11 or something. It still gives 7. Okay, so very dumb Fibonacci. Okay, so let's analyze this one. So if it's of the first index, it should give 0. Okay, so like let's put like okay, like there is a thing called condition in Clojure. Okay. Uh, Okay, so oh, okay, test expression, blah 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 blah. I don't understand a thing over here. So let me just go to the Clojure document. Okay, there is this thing called memoirs. Okay, I need this. Okay, so I also need a thing called cont, C-O-N-T. Okay, so okay, condition. Okay, so this is how it is. Okay, so condition and okay, so this okay, just check something and then return something. Okay, so that's the thing, right? Okay, so let's try it on. Okay, so it is a function, right? And to it we just pass like okay, index is equal to 1. Okay, then we say return 1. Okay, if index is okay, return 0. Okay, so that's the thing. Okay, if index is equal to 2, and then return 1, right? So that's what I just say, right? I don't know why this is not aligning. Tab, yeah. Okay, so that's the thing. So at least yeah, it works a little bit better now. So fib, fib of 7, yeah, let's try it. Why not? Okay, so it returns nothing. Okay, so for that thing we need to take care, and then like okay, yeah, fib of 1 and you get 0, and then fib of 2 you get 1. Okay, fine, very good, right? And then in condition you have this thing called else. Okay, so what we are just doing is okay, else, and then okay, yeah, fine, we need to return something. Okay, else. Okay, so for everything else in Fibonacci we just look like it's like addition of previous two. So okay, if the index is 3, it is like fib of 1 plus fib of 0. That is like fib of 1 plus fib of 2. That is nothing but fib of 3. And similarly, like fib of 4 is nothing but fib of 3 plus fib of 2. Okay, so that's how it is. So we just put that formula. Okay, so like it's like fib, and then over here like minus index 1, that is like index minus 1, and then this other thing fib. So we just put it. Okay, so else means this one and all those stuff. Okay, so I don't know why it's showing an error and all those stuff. There is an error. So what did I do? Too many braces. Mm-mm-mm. So I did something over here. Right, so right. Yeah, I gave the expression wrong because I'm not good at Clojure, right? Okay. So for the else, okay, so first let's open a plus over here. So even now it's wrong. Okay, okay, fine. Else. We're just putting plus. Okay, so and then over here we're just putting like okay, fib of minus index 1, right? And then another one is fib of right. And is this extra brace? Yeah. Yeah, let's put it as else, right? This thing of highlighting is really good, like in VS Code, right? Okay, so I'm able to find errors even before I run the function and all those stuff. Okay, So let's put like, okay, fib of 7, right? Is it 8? Yeah, it's 8. What is fib of 9, right? 21, yeah, I think we cracked it. Okay, so this is how you just do Fibonacci, right? So, but then there is another thing, right? So, if you want fib of 5, okay, so I'll just put it like this one, like, okay, like fib of 5. What this will do is like this will want to calculate, okay, like okay, like there'll be two stuff, okay, so this is nothing but plus of, just look over here, it'll be plus fib of 4, right? And then fib of 3, right? And similarly, fib of 4 is nothing but, okay, so let's tap this out. So fib of 4 is nothing but, okay, like fib of 3, right? Plus fib of 2, right? Okay. So similarly, like this fib of 3 is nothing but like, okay, like once again, like if you just try to put it over here, like, okay, fib of 3 is nothing but, this will just keep on going like a tree. Fib of 2 and then, okay, so fib of 2 and then fib of 1, and once again, like you can just keep expanding this 3, this fib of 3, 3 over here also. Okay, so similarly fib of 2 is nothing but fib of uh fib of 2 is nothing but 1. Okay, so like fib of 1 is 0, so that's how it just keeps on going. So let's say a bigger number, you'll see like there's a lot of recalculation. Okay, so fib of 3 is called once, twice over here, fib of 4 is being called once, fib of 2 is called thrice, and this fib of 2 will also call fib of 1. No, fib of 2 and fib of 1 won't call. This will once again call, okay, let's say like this will once again call this one, like this fib of 2 and fib of 1, right? So this will happen over here. Okay, so you just, I hope you see the problem over here, right? So what we are just, what's happening to us is like we are just calling stuff a lot. Okay, fib of 1 has been called many times. Okay, and then yeah, so fib of 1 is called 1 2, and fib of 2 is called thrice, and so on and so forth. So there is a function called time. Okay, so there is a function called time, right? So let's time it. Okay, so time. Okay, fib of, okay, 20. Okay, so like it says like, okay, 2.82 milliseconds. Okay, milliseconds is low. Okay, so let's go on for 200. Oops, did I crash it? Oh no, I think I crashed it. Not good, not good. This is not good. You shouldn't keep crashing stuff. Flip of 2. No, I think I crashed the ripple. Okay, so once again, lean ripple. Ah, the same port. Okay, that's good. Oh, no, not the same port. Okay, generic. Okay, what about the port? Okay, so let's give like, okay, like time fib of 10. Okay, yeah, I need to run all this stuff. Okay, so okay, 0.192 milliseconds. Okay, so let's put it like 15. Will it crash? Yeah, so 0.12, so it's increasing 9 times. Okay, let us put it like, okay, uh 16. This one is taking less time. 18. Okay, so it's coming like 1.314 milliseconds. Okay, let's put it like 30. Okay, so it's coming 120 milliseconds. Okay, this is a good decent estimate. Okay, so let's put it like 40. Oh, that's the limit. Okay, that's where it crashes. Okay, so that's the limit. Okay, maybe it's overflowed or something like that. Okay, Control D. So Fibonacci is not so efficient if we just do it like this one, right? So okay, like 63701. Okay. So you get it, like why they're saying like they put it in that book, like algorithms and all those stuff. Look, this one will 63701 will consume your computer resources and 63701, yeah. And will do something. So it'll just mess it up. Okay, so even for small numbers. Okay, so that's the thing. Okay, so let's run this. 40 is the high mark, so 30 is safe. Okay, so time fib 30, right? Okay, 113. Okay, so there is a thing called, okay, in order to make it work even for better, what we can just do is like we can tell Clojure to memorize. Okay, so it'll memorize like, okay, Fibonacci of 4 is what, like 2. Okay, Fibonacci of 3 is what, 1. Okay, so it'll just memorize. Okay, it'll just keep memorizing, and so okay, so let's say what is fib 2 over here. It's been called 1, 2, 3. Okay, 3 times over here. Fib 2 is 1. So rather than just executing the function, it'll just memorize it and then it'll just use those values. Okay, so that'll run more efficient. Okay, so that's called as memoization in programming. So yeah, so there is a function called memoize. Okay, memoize. Okay, so this is how you just do, right? So and in fact they have explained with Fibonacci. Okay, so okay, right. So what you just do is like, okay, like usually the convention is, okay, so FN, okay, MEMOIZE, memoize fib, okay. So this is a definition we are just giving, and then to this we are just passing this memoize, okay. So the output of memoirs, and then and I think we are just giving fib. That's the thing, right? Yeah, we just need to give the function name. So we just need to give the function. So fib. Okay. So this is how it just works. Okay. So uh, what happened, right? Okay. I should have given def. Okay. Okay. So memoirs fib is there. Okay. So that's the thing, and I can just do something like, okay, like memoirs fib. Okay. So and then let me just time it. Memoize fib. So this itself will give some very great difference. Okay, so 30, right? Okay, in fact, it is giving more this thing 118 milliseconds. Okay, but then now let's try to crash the program. Okay, so 40. Okay, so now I just don't know like what's wrong with. Okay, this isn't memoizing it. Oh, it worked. Look, it worked, right? So 40 crashed in previous thing, but over here it just worked. Okay, so that's the thing. So yeah. Okay, right. Okay, so let me just try it once again. Memoize fib and 30. Let me see whether the time is reduced. Look at this. Look at this. Elapsed time. It's just milliseconds and so less. Okay. Okay, so let's time this one. Like time. I thought I crashed this. Okay. Fib 30. Right? 514229. Right. Okay. Fine. So look at the difference. Okay. 122 by. Okay. Like let's even compute it. Okay. 122 by point not 2. 122 by. Okay. Point not 3. Let's put it as point not 3 itself. Okay. Let me put a 0 over here. It's 4,000 times faster, right? By memoizing it. Okay, so is it correct? 122 by 0.03, right? Calculator 122 by 0.03, right? Yeah, 4066. Yes, so 4067 times faster. That is like, since it just memorizes, it can just use that value. So it'll just know like, okay, uh, at one stage it'll just know by heart like Fibonacci of 10 is so much. So no need to recompute. Okay, so that's how it is. So this is how you just calculate Fibonacci in Clojure. Okay, so and let me just put like, okay, like memoize fib 10. Okay, so right. So this time and all, yeah, like I'll just put it in my notes, like notes in my blog. Okay, so that's how it is. And I also put this one as notes and the link of the book and everything in the notes so that like you can just get it. So this is how you do Fibonacci. So even though it looks very simple, look at the computational complexity and look how we use memoirs and time to gain insights and to reduce the computation and all those stuff. Okay, so that's the lesson in this video. Okay. Anyway, thanks for watching. Let's see in next video.